Okay, so we certainly aren't doing this. That is calculus. If that was freaking you out at all. Let's see if my internet is back. Yes. All right. So today, I really, again, am here to answer questions, talk about anything you have issues with on your homework. I gave you that more whatever, problems. I think you probably started to see some repeats, some things, and that was the thing you need to be focusing on. So the repeat ones are the math team questions are generally ones that will show up on your test. Another thing I want to caution you about is people tend to get so wrapped up in the logs they forget to go back and look at the inverse stuff. Remember inverses where you switch the x and the y and you resolve? Remember how to sketch an inverse? How do you sketch one? You take a bunch of points, switch the coordinates, and then regraph the other ones. And what should it be a reflection over? The x equals y line. Well, good. Y'all remember a lot of that. That x equals y line. But go back and review that. Or composite functions. Do y'all remember how to do like f of g of f of x?
Switch the x and y.
No. That's for inverses. Yeah, but if it's a composite like f of g of x.
Oh.
Do you remember how you take the g function and you put it inside the f function? Maybe go back and review those a little bit if you struggle with them at all. And just make sure you're in good shape because that kind of stuff does show up on this test as well. But I want to answer any questions you guys have on either the last two nights or on the review sheet. And if you don't have any questions and you're like, man, I love logarithms. Like I had a guy in 5th period who was like, this is by far my favorite unit. And I was like, really?
Was it Luke?
It was not Luke.
It was not, okay.
You're close. He did say that?
Yeah, they're just puzzles with like a bunch of different solutions, or a bunch of different ways to get the
Oh,
solution.
that was a lucky guess. Just threw a number in there. I like them because initially there's so many log rules, your brain starts to fill up and it's like going, but once you do enough of them, it's kind of like, hey, it's going to be this or it's going to be this, and you can stick to those log rules. And what makes it really difficult maybe at a math team level is them bringing a bunch of other junk in, like maybe a system of equations or something like that. But again, if you understand the stuff we're doing on this page and you understand the review sheet, I think you're going to be in good shape for this test. All right, so looking at this, or if you did this for homework, remember I do want your homework tonight, but you can give it to me before. I tell you what, I want you to have this to study. So your homework that was due today, you can give it to me tomorrow, and I'll probably take up your review sheet too. You just give me that more thing and the review sheet tomorrow. Because I do want to kind of see that you're doing stuff. But on any of this, did anybody have a question? Yes?
Number 14.
Okay, so let's jump to 14. All right, so it says solve. We've got a couple of variables in there, and I'm adding logs. And before I do that, can I right now, because my bases are 5, am I allowed, question mark, to exponentiate right there each part of this to get rid of those logs? I am not allowed to do that, okay? It's just not a log rule. So I'm not allowed to do that mathematically. It doesn't make sense. What can I do, though, so I can put it in a position to be able to exponentiate? Okay, so I got to get rid of this 2/3 or any other coefficient. If I do that, I end up with a 2/3 power, which is a little nasty. Now can I 5 exponentiate? No.
It's not
Let me show you why. Is this a true statement?
Yes.
If I'm allowed to exponentiate, I should be able to exponentiate anytime. But clearly, 9 plus 27 is not
Oh my goodness.
243, is it? That's not true. Now, this is true. 3 to the 5th is 3 to the 5th, but I don't know what I'm doing at this point going 5 to that with 2 logs. I don't have a log rule for that. So how do I take these 2 logs and make them 1 log so that I can exponentiate? So before I exponentiate, after I move the 2/3, to add 2 logs, I combine it into 1 log by doing what? Multiplying. And what is an n to the 1/3 times an n to the 2/3? How do I multiply like bases? Add, keep the base, and add the exponents. So that gives me log base 5 of m to the first. And now that I have a single log on one side, or at least maybe a log on both sides, but I don't have it on either side, now I can exponentiate. So I get n equals 5 to the third, which is, isn't it nice knowing powers? I mean, they show up so often. Once you get them down, you're in good shape.
We did number 15.
Okay, 15, does that look familiar?
Yep.
Yeah, we had one like that before. Again, I've given that problem many times on a test before, whether it's on yours, we'll see. But the key to kind of getting this is a couple things. One, going x minus 1, oh wait a minute, that factors to x minus 1 squared. And then the second key here is recognizing that these right here are two different things. There's a big difference between squaring an entire log and squaring what you're logging. Are you with me? So what do I do with this?
You swing the 2 on the log on the right.
So if I swing that 2 over to the front, it's no longer there. Now, is there something I could do to make this look less complicated? Like make a substitution? Since I see log base 5 of x minus 1 twice, what if I said let a, it's an a, equal log base 5 of x minus 1 here and here? Wouldn't that give me a quantity squared equal 2 times a? And what do we say about dividing by a? If I divide out an a, I'm throwing out a what?
An answer.
An answer. I don't want to do that. What I want to do is not divide it out,
Move to the left side of the back.
but set it equal to 0 and factor it out so that I now have that a that would have been divided out representing a solution. Now I got to do a little bit more than this, right? What do I have to do now?
Plug them back in.
Plug that back in for my a. Sorry, I'm going down a little bit here. I'll come up here. So a, which is log base 5 of x minus 1, can be 0, and a, which is log base 5 of x minus 1, I'll put it right here, log base 5 of x minus 1 can be 2. So all of this work just to get it to a point where I now have 2 logarithm problems. And how would I solve those? Exponentiate gives me x minus 1 equals what? 5 to the 0. So x is 2. And then exponentiate here. And you get x minus 1 equals 25. X equals 26. And then you double check. Does 2 work there? Yep. 2 work there? Yep. Does 26 work there? Yep. Yep. As long as I end up with positive values, I probably can trust on that.
On the review, number 9 is like 1/3.
So not this thing, the review.
Yeah.
Right, so
Yes.
it says write as a log of a single number. So right now I have the log of 2 different numbers.
Would it just be log b to 8 and then you leave the 1/3 on the inside?
Well, let's see. You're saying to subtract these, I can combine it into 1 by dividing those 2 things. And 72 over 9 is 8.
Yeah.
So rather than write 72 ninths and then rewrite it again, I'm just going to write 8. And then drop the 1/3 down. Now, a lot of times there's a question about this, and it's a good question. People are like, well, what's the right form? What's really simplified? We don't really have a PEMDAS here. So is it bad to have a number up front? I would normally say no. If you wanted to leave it like that, what's the big deal? But if when you swing it, it really helps, then do it. Like for instance, if I had this, if I had 1/3 log base b of 12, and I swing it up there and I get log base b of 12 to the third, or log base b of the cube root of 12, it really didn't make it look a whole lot better, did it?
Yeah.
So what's the point? But if I swing the 1/3 up here, log base b of 8 to the third, isn't that the cube root of 8?
Okay.
And that's nicely simplified to log base b of 2. So it's one of those, a little bit more of a judgment call for you. Is it always going to be better to swing it up? I would say no. You got to realize too, if you happen to use logarithms in your life at some point, it's going to be to get values and expressions, and they're going to all go through a calculator anyway. So the whole simplifying thing, I really want you to know how to simplify. So if you do run into a multiple choice question and you have this, but it's not an option, but that is, that you'll know how to simplify. Or if you have this, and you look down at A, B, C, D, E, and it's not an option, but this is, that you'll know how to simplify and see which one fits that. What else?
For number 10, like I know that you combine it, or like you keep the base and it's like 4/3.
Okay, so for this one, you don't have a problem, right? Log base 5, when you subtract logs, you divide what you're logging, right? Well, how do you add a 2 in there?
Yeah.
You gotta change 2 back into a log. Now, what have you noticed about every log on the planet that is equal to 2? Those match. Right? Whether it's log base 5 of 5 squared, log base 10 of 10 squared, log base 12 of 12 squared, they're all equal to 2, right?
So I say 5 since those are both 5.
So if I wanted to match this, make them 5s. So log base 5 of 5 squared,
And then you can multiply.
and now I can take the 4/3 and multiply by the 25, and I would get, yeah, log base 5 of 100/3. I gotta be honest with you, I wouldn't do it in 2 steps though. I would have done this. I would have said, change that to a log base 5 of 5 squared, and then stuff that's positive, 4/25 on the top, stuff that's negative on the bottom. And you jump right there.
Can you do number 19?
On this, okay, so it's an equation. I'm asking you to solve. About one of those Nick Saban masks that he wears on the sidelines. They're the worst. Like they itch your face just horribly. I don't know how it stands.
Talking about the one you just wearing?
Yeah. It's almost, it looks see-through, like you can see through it.
Oh, yeah.
But it has this really thin fiber thing, but it feels plasticky. And like if you have any kind of like base hair, it like grabs them and just
Yeah.
pulls like it's just awful.
Is it easy to breathe through or something?
It's easier to breathe through, but it doesn't outweigh the suffering that your face is like just dying. It's like somebody's just sitting there rubbing on your, I don't know. Money not well spent. 19. So anybody have an idea? I got logs, they're being added together, I got an equation. I mean, ultimately it's solved, so I gotta get these x's solved for.
Multiply everything by 2.
Now, multiplying everything by 2 is not a terrible idea, because multiplying everything by 2 would get rid of those fractions, but not that one. But 6 would do it, wouldn't it? So if I just multiply by 6, and I doubt my key does that, but that's what I would do. I think that's a great idea. So 6 times that gives me a 3 log base a of x plus 2. And then 6 times that, because you got to distribute, right? Another 3 log base a of x minus 2. And then 6 times that gives me a 4 log base a of 27. Now what? Can you just cancel those logs out?
No.
Can you exponentiate with an a?
No.
Can you swing the 3's and the 4's up?
Yes.
Okay, let's try that then. I'm going to swing that 3 up. I'm going to swing that 3 up. I'm going to swing that 4 up. And I'm not even going to multiply that out. I don't know what 3 to the 12th is anyway off the top of my head, but I'm hoping that it cleans up a little bit later. Now can I exponentiate with an a?
Yes.
No. We just talked about that with the 2 plus 3 equals 5, right? There's no rule that says you can exponentiate each part. There's a rule that says you can exponentiate each side. But I don't know how to exponentiate a log of something plus log of something. I don't have a rule for that. You can make one, but it's easier to not make one and say, how do I add 2 logs? Keep the log and multiply these 2 things. Now what? Now it's either 1 to 1, because you have one log and one log, or you could exponentiate, right? But either way, what happens? The logs cancel. Now here's where you got to do a little bit creative math, and based on my key probably did it a different way, but I'm just going with what you told me to see if you can bail yourself out. So here's what I currently have right now. Now, is there any part about this that's bothering you more than anything? Which ones? The threes are kind of bothering me too, because I fear that I may have to FOIL all that crud out, and that's going to be truly awful. Or maybe I could get rid of the threes. How could I get rid of them? Cube root both sides. So if I cube root the left and cube root the right, the cube root of that product just leaves me x plus 2x minus 2, right? And what's the cube root of 27 to the fourth? I don't have to do it to the fourth and then cube root it. I can do either way. So if I cube root it first, I get 3 to the fourth, which is 81. If I do 27 to the fourth, I get some massive number, like, I don't know what, and then I'd have to cube root it, and I'd get back to 81. But I don't know what that 3 to the 12 is, it's big. Or if you think about it like this, isn't 27 3 cubed to the fourth, which is 3 to the 12? And isn't that 3 to the 12 thirds, or 3 to the fourth? You could think that way too. But I think that's more trouble than trouble. And at this point, what are you doing? X squared, foiling it out, right? And then you're going to add 4x squared equals 85. And you get x equals the square root of 85, which to my knowledge is simple as it comes. Technically it's plus or minus. But can I have a negative root 85 up there? Yeah. Well, that's possible, but in this case, no, because root 85 is bigger than 9, right? So if it was negative, that'd be like negative 9 plus 2. That would still be a negative. So toss, keep the positive. Y'all seen that? Yeah? What else you got?
32.
Okay, so I got e to the 2x minus 7e to the x plus 12. What do you smell? I smell a substitution problem, which probably means it's factoring. Now, if this was e to the x times 7e to the x times, I would probably think, I probably need to get those e to the x's together and then do maybe an exponentiation or something. But this, I'm thinking, let's take that e to the x and that e to the x and replace it with something. So that would give me a squared minus 7a plus 12. And that I can factor. I feel a lot more at home there. A minus 4, a minus 3, a equals 4, a equals 3. And then when I plug it back in there, it just looks better, doesn't it? And I avoided all the ugly of that. Now, a lot of you can actually leave it in there. Like I have people that will just look at that and say, I don't really need to do all this substitution. They'll just say, if it's e to the x squared, I got an e to the x, e to the x. And if it's 12, I got 4, 3, negative, negative. And then you'll jump straight to here. Great. You don't have to make a substitution. It just sometimes helps people see it. And then how do you solve? Do what? Yeah, I plugged that e to the x back in, but how do I solve it at this point?
Do that like ln.
Yeah, I got an ln both sides. Because how do you get rid of a base of e? You log with the base of e. And what's a log with the base of e? ln. So even though I'm writing ln, and by the way, don't do this. Every year I'll have somebody do this. They'll go, oh yeah, ln both sides. You're not multiplying by ln. It's the log of a number. So that doesn't make sense. You are logging the positive 4. But log base e of e cancels and leaves you, so log base e, ln means log base e of e, it gives me x equals ln 4. And then here, natural logging both sides, log base e of e, x equals ln 3. And what would happen if you ended up with something like this? What if? What happens when you log both sides here? What does x equal? Nothing. I can't log negatives. Right? So do remember that. Or if it's a 1, what does that mean?
Pretty good.
Yeah, and anytime you log a 1, you get a 0, as long as it's defined on the base. And it is, it's log base e. But this one, you might have been able to bail yourself out and say, oh, 1 is the same thing as e to the 0. Oh, x must be 0. But the log rule still holds. What else? Y'all feeling this?
Number 16. Like, I know how to like set it up and stuff, but since there's like a random tulip for.
Yeah, there's all kinds of junk going on there. So, definitely a math team looking question. Let's see if we can get there. So, this is what we have, and I'll enlarge it. This is basically like 4 raised to a logarithm with a base of 2, and you're logging a 2 raised to another logarithm with a base of 2 of 5. And that may help you see it a little bit better, but that's basically what you're doing. Because look at this, you're logging the 2, here you're logging the 5, so that 2 and that 2 are bases, and this is the base of the exponent. Now, is there anything right now that you can see that you can do?
2 squared. Like,
I could.
oh wait, you can.
But even before that, is there anything you can cancel that might help you?
Two or 5.
Yeah, isn't all this 5? Yeah. 2 raised to the log base 2 of 5 power is just a 5. So I'm going to put a 5 in there, and that gets me this. 4 raised to the log base 2 of 5. Now, I can't cancel that because these don't match. So there's 2 options. One is to change that 4 to 2 squared. That would give me this. Now can I cancel the 2 log 2? No. Why? Because here's my rule. A log A of B is B, but only if there's a 1 sitting out front of that log. And you don't have a 1 sitting out in front. So what would you have to do? I could swing that 2 out there because power to power is going to multiply anyway. So I could swing that 2 up. Now I have 2 log 2 of 25, which is 25. But there is a shorter way to do this. Like much shorter. Check this out. Is it true that if I have a logarithm, or you tell me if it's true, that I can raise that and that to the same power?
What's that?
If I have a log base A of B, if I want, I can't multiply them by a number, but can I raise them to the same power? And if you can, tell me why. Say it again? Sort of. You might not be thinking the right thing, but you're kind of saying the right thing. Don't I have a rule that lets me swing that M to the front? Right? And don't I have a rule that lets me swing this one to the front but on the bottom? So is that true? And what's M over M? So technically, if M over M is 1, that's not affecting anything, is it? So if it was 6 over 6 or 5 over 5 or 4 over 4, it's still 1. So it doesn't change anything? Well, if that's true then that means that I can swing the M's up. And basically that's saying that you can raise either of these numbers to any power you want. Okay, well with that in mind, what could I do to that 2 to make it be a 4? Square it, but if I square it, I would have to square the 5.
Oh my goodness.
So now I have 4 log 4 of 25. Cancel, cancel, there's your 25. So if you know that rule, which it's somewhere on your sheet, or your list of stuff, it's kind of nice. Which means stuff like this. Like guys, if I had log base 64 of 25, is that the same thing as log base 8 of 5?
So you're giving us this rule where you can square both of those and it's the same thing?
I've already given it to you, yeah, but if you have a log, I can take that and raise them to any power. And since roots are powers, I could take the square roots of either one, or cube roots of either one, like right here. Could I square root the 25 and get a 5, square root the 64 and get an 8? Now, if you cleaned it up, isn't 64 8 squared and 25 5 squared? And if you swung the 2 out to the front, the 2 out to the front, aren't they going to cancel? So it kind of proves the point, but yeah, that's a great little rule that might or might not help you. I mean, it's probably not going to help you very much in a problem like this. Like, what if I give you log base 16 of 32, and then there's an 8 down there, right? I tell you what, forget the 32. Like, on something like this, tell you what, like if I take the square root of both of these, that doesn't become 8, does it? So sometimes it doesn't really help you. Now there is some power that I could raise those to where it would become an 8, but sometimes it's probably just easier to go, you know what, why don't I just do this? Change 8 to a 2 cubed, change 16 to a 2 to the 4th, and then what could I do with that 4 that's right there? I could put it under that if I want, or what could I do? I could make it a 1/4 up here. Remember, a 4 down there becomes a 1/4 up here? But why? Because that 3 is going to be right there when I swing it up. And if I make that 4 a 1/4, doesn't that 1/4 end up here? So again, you could just say a 4 there becomes a 1/4 there, and then you could cancel. So that rule that I just showed you over here, it's not always a great one, but it is one. It does work sometimes to help you out. But sometimes the best way to go is just to rewrite them, swing all the powers out to the front, and then swing them all up top, and then they match. Y'all seeing that?
Can you use 16 on the more?
Sure. Okay, good. I'm glad you asked me that because we kind of raced through that at the end, or maybe you didn't even cover it. So here's the idea behind this problem, and then I'll show you how to do the problem. But don't memorize your way. Think. If I ask you how many digits does 5 to the 27th have? Do you have any idea? I don't. If I said how many digits does 10 to the 27th have? Do you have any idea? Why? Because 10 to the 27th has 27 zeros and a 1. So you're saying if I could somehow write numbers as a base 10, I'd have some insight. Because base 10 means you have a bunch of zeros and a 1, right? Now that's true for whole numbers. Like look, 10 to the 20th has a 1 with 20 zeros. Right? But what is 10 to the 20.3 have? Now let me show you. It doesn't have zeros because it's not a whole number. 10 to the 20.3 is something like this. 1 9 9 5 2 6 2 3 1 5 blah 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 blah. Now it still has the same number of digits as this. It's just not a 1 with a bunch of zeros. Are you with me? So I'm using the mentality of if I can count digits with that, then I can still count digits when it's a decimal. It's the same number. Are you with me? And because I know it's the same number, because it's not until I hit 10 to the 21st, right? All of this, 21 digits. It's not until I get to the 21st where it becomes what? Right, until it becomes 22 digits. So anything in between here is still a 21 digit number, it's just a slightly bigger 21 digit number. But not quite yet where you have that extra digit. You following me?
If it was like 10 to the 20.5, would it still be 21 digits?
Yes, look, if it's 10 to the 20.5, instead of being 199, 21 digit number, 10 to the 20.5 ends up being 3.162227766, yada, 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 yada. But still, 21 digits, just a bigger 21-digit number. Why do I know that? Because it hasn't yet become a 22-digit number, because the 22-digit number doesn't show up until it hits 21. So anything bigger than 20 is still going to be a 21-digit number. So with that in mind, how does that help me here? Well, I have no freaking idea how many digits 2 to the 122 has. But here's what I do know. That. So if I know that, and this is a base 10 log, look what does that mean? It means something more than you think. It means that if I exponentiate and the 10 log 10 cancels, I just found another way to write the number 2. Look at this. If I take 10, and raise it to the 0.301 power, what do I get? Now it doesn't say 2 because what? What does it say? 1.99986. And why isn't it exactly 2? Because that's an approximation. Log of 2 is really this. 0.301029997, yada, yada, yada. And if I actually took 10 to that power, check it out, 10 to that power, look what that gives me. 2. Now it actually rounded, but because I didn't put the exact value, I did put the exact value in there, I guess. It went exactly to 2. Well, this is an approximation question, but what it's doing is it's giving you a bailout. I have no idea what that is because I don't know how 2's react. But if I know how 10's react, based on this, couldn't I turn this expression into 2 to the 122nd by just raising both sides to the 122? Now I've got 2 to the 122 represented as a base 10 number. Now I gotta do a little math, right? I know that's no fun, but I usually have a way to make that easy on you. But even then, it's not that hard to multiply these two numbers together if you're careful. That gives me 36.722. So a few seconds ago, you just told me you had no idea how many digits that has. But now that I've rewritten it as a base 10, how many digits? This has 30, you have to think, it's like 36 zeros and a 1, right? 37? Now it's not 36 zeros and a 1, is it? It's probably some other weird number in there, but it hasn't yet become a 38-digit number, has it? It's still a 37-digit, just like this one would be. So we say it's 37 digits. And magically I know that, even though I have no idea what the number is. No idea. Y'all with me? I've seen that problem asked, I kid you not, at least once a year, every year I've been here. And in the early years, in the 90s, they would give you this. Now they don't even give it to you. They just say, how many digits does that have? And if you don't have memorized that log base 2 is 0.301, you're not going to get it. In fact, one year, if all you had memorized that it was 0.301, you missed it. You had to have memorized that it was 0.30103. It's actually 3010299 or something like that. But if you had it memorized to 5 places, you got it. So sometimes they're just brutal and stupid, but I'm not going to make you memorize, or maybe I give you the value or something like this, of something that I only want you to have memorized for bonus, what log of 2 and log of 3 are. And with those, you can find other stuff. It's probably the easiest bonus in the history of bonus, because I'm telling you what I'm giving you. If you know them, you can find other stuff. What else you got? On the review? This? All right, so you're solving for x. What's in your way? Okay, so what's in your way is just x is buried in that logarithm. So getting rid of the log would probably go a long way, wouldn't it? So if I exponentiate within x to that gives me a 5. X to that, I'm just going to write down for now. Now, what's in your way now of this x being by itself? So how do you get rid of a negative 1/3 power? Yeah, why not? Not multiply, but raise it to a -3 power. And why does that work? Why does raising it to a -3 power work? Because power to a power, you multiply, and that will leave you x to the first, and that's your goal, right?
Wouldn't it be negative 125? Because 5 to the negative third.
Well, what does a negative tell you to do? It doesn't make it negative, it does what? Flips it. Yeah, so you're going to cube it, which is the 125, but the negative exponent tells you to put it on the bottom. That's all the negative exponent means. You know, like 3 to the -2 makes it on the bottom a 3 squared, which is 1/9. But it never makes it a negative number.
Can you do, this is like a stupid question. Can you do number 6?
It's not, because I gave it to you. I really need you to know that. So, yeah, don't feel bad. Right here, so F inverse. Now, I want to show you a little trick on this. It might save you a little time. Do you remember how to find an inverse function?
Yeah, you switch
You switch the x and the y. Guys, that's it.
Solve for y.
That's the making it pretty. The inverse part is switch x and y. This is your y, that is your x, right? So if you're switching them, now you have x equals 6 to the y. Now that technically is your inverse. That's your inverse relationship right there. I just solved to make it pretty. Are you with me?
Mhm.
So to make it pretty, how do I get y off its perch?
Log base 6.
You gotta get rid of that 6. How do you get rid of the base of 6? You log both sides of the 6. So when I do that, that is what makes this end up being pretty, is logging both sides. So now, if I know that y is log base 6 of x, I can rewrite that as a inverse function. Right? Now, right here, once you have your function, your inverse function, then it's just saying plug 36 in. Right?
Can you just plug it into the log, like for x?
Yeah, because whatever you have here goes here. And now that I have that function, right, it's saying if I know that the inverse of x is log base 6 of x, then the inverse at 36 is log base 6 of 36, which we know is 2. And right here, same thing. If I know that the inverse of x is log base 6 of x, then the inverse of that is log base 6 of 1 over root 6. But can I simplify that? Good. Yeah, 6 to the half is on the bottom, but I can't have it in the bottom. So I make it 6 to the -1/2 in the numerator, and now I can apply my rule, which is -1/2 over 1, which is -1/2.
Wait, on number 2, how'd you get, or, you know, number 5, how'd you get 2?
Because 36 is what?
6
And my rule is that 2 over that 1 is 2.
Oh, yeah, that's right.
Now there's another thing you could have done. Technically, I'm saying plug 36 in for the x in the inverse, right? Even if I wasn't able to solve this, and sometimes in AP Cal you can't. And if you're wondering, what do you mean you can't? Like, what if you switched your x's and y's and you ended up with this? How are you solving for y? You aren't. But look, I can still maybe get somewhere by plugging the 36 in for the x, because this is my inverse relationship, right? It's just not pretty. So I could say, oh, well, if that's my inverse relationship, check it out. If my inverse relationship is this, I could still plug 36 in there. 36 equals 6 to the y. Could you still solve it by common sense? Or right here? Is that making sense what I'm doing? So right here, if I know that x equals 6 to the y is my inverse relationship, and I'm supposed to plug that in for x, isn't 1 over root 6x 6 to the -1/2? Again, I'm using an inverse function, but a lot of times you'll be in a situation where you can switch, but then you can't resolve. What do? Well, you still take that x value and you plug it in. And sometimes you can eyeball it, or you can use your calculator to solve. Like we'll learn that later when we all have graphing calculators, how to solve an equation like this by just graphing it and looking for where it hits the x-axis.
Can we do a composite?
Yeah, pick it.
15.
On the review,
Or is that?
What's it?
That's what-
these two. Okay, so if I'm doing these two right here, we'll do 14 and 15. 14 says find f of 1/2 first. So what's f of 1/2? Well, I'll come over here and I'll say f of 1/2 tells me to take the log base 2 of 1/2, get that, and then plug that answer into my g. So what do I get with log base 2 of 1/2? 1. So -1. Y'all see that? Because that 2 to the 1 on the bottom is 2 to the -1. I'm basically simplifying this, which gives me a -1. So now I gotta plug -1 into my g function, and I get 4 to the -1, which is 1/4. So all of that's 1/4.
At first I thought like does not exist because I thought like the -1 couldn't come out, but I know like I know.
Yeah, but that's different than logging a negative number, right? I'm really logging a half, which is a positive number, using a negative exponent. Now f of g of x tells you to do what? Take the g of x function and take that whole function and do what with it?
Put it in there.
Plug it into my f function for x. So to do that, my g of x function happens to be 4 to the x. I'm going to plug that in the f function, and I get log base 2 of 4 to the x. But I can simplify that. How?
That's 2 squared.
So 4 is 2 squared, which gives me log of 2 squared to the x. Is that the same thing as 2 to the 2x?
Mm-hmm.
Think about it. 2 squared to the x, power to a power, multiply. And then 2 to the 2x is the same thing as 2 to the x squared. I mean, you can flip-flop all these back and forth. But anyway, bottom line is, or 2 to the 2x, right? And once I get to there, then what can I do? The 2 and the log 2 cancel, and I get 2x over 1, which is 2x.
Can we do number 29? Because like I don't like the e's and the l's.
Yeah, yeah.
Guys, and I know in your brain,
It's figures.
first of all, in your brain, E means about 2.7. It means way more than that. It's not like a pi value. I know you haven't dealt with E much, but in calculus we deal with it a ton. And exponential growth and decay, we deal with it a ton. So it's a very common number, but it's a pi-like number where pi shows up with circles in geometry. E shows up in continuous compounding. And that actually happens a lot in our world. Okay, whether it's finance, bacteria growth, radioactive decay, all that stuff is decaying consistently, which means a continuous growth or decline pattern. So E is a big deal. So we got to understand it, but remember, E is just a number like pi. It means about 2.7. ln is just a log of that number. So don't let it bother you. If you have to physically think, wait, I got an ln here. ln, this means log base E of log base E of x. That's what it means. So if you were solving this, what would you do? Exponentiate, except don't write that. Just think it. What you're going to write is E, and remember this is a log of a log, not a log plus a log, right? If it was a log plus a log, we'd need to combine first. So E to the log base E does what over here? Drops the ln x, anything to the 0, 1. And then E to that, E log E cancels. So think that, but write that. But when you have an E, guys, don't change an E to an ln. E is a number. It means like 2.7-ish. So right here, if you had, or 3, think of it like a 3. If you had 3 to the x to the 5th equals 1,000, what would you do to get this x by itself?
Root 5 to the 1.
5th root it? Why not? 5th root it?
And then
And that gives me, that cancels and leaves me 3 to the x equals the 5th root of 1,000.
you know it's log 3.
And then I'd have to log base 3 it. Now that's what you would do if it was a 3. It's not a 3, it is an E, but don't let it bother you, because right here, instead of log base 3ing it, you're going to ln it. So I'm gonna ln that, ln that. It gives me x equals ln 5th root of 1,000. That's about all I can do. I mean, I guess I could think about that as 10 maybe to the 3/5 and swing a 3/5 out front. But again, is a 3/5 better out front? Is it better as the exponent? It doesn't really say. There's no rules for simplifying that way. So I'd leave it. And over here, what are you going to do to solve for that e? Square it. So if I square it, the square and the square root cancel? It's not very clear. Brown is struggling today. And now, how do I get rid of the e? Again, yeah, log base e, which is ln. ln of e is log base e of e. It cancels. Nothing cancels there, though. And then at this point, add a 2. Now, I would let you leave it like this. Sadly, at Vestavia, you won't see that as an answer.
Depression.
Because guess what they're going to do? They want you to add a number to a log. Can you do that directly? No. Can you change it to a log? What log would have a 2 there that would add to this?
ln e squared.
ln, log base e,
E squared.
of e squared would be 2, right? So you would, I'm fine with that on this test, unless I start you with that and say combine it to a single log. So leave these like this. But if I did say combine it to a single log, how would I now add these 2 logs?
Keep the base and
Keep the log, 9e squared.
Mr. Hurry, on 31, when you did the you log, or you put the e below the ln,
Yeah, I'm exponentiating.
how'd you get a 1 on the right side?
Because e to the 0 is like 3 to the 0, 5 to the 0. They're all equal to 1, right?
And then you end up getting ln x equals 1, and then that's,
Correct. Right?
and then how do you do the e again?
I do it again. Every time I want to get rid of a log, I'm going to do that.
That's good.
See what I'm saying?
All right, guys. Yep. Y'all have a good one.
Mr. Hurry, can you make one really quick for me?
Sure.
Can you do one 28 through 22, one of those?
On this review,
Yeah.
okay, so these are more just rules. This first one, that's log base e of e squared. So what happens? On the log base e of e squared, what rule comes into play? You can cancel and you get 2 over 1. So that's equal to 2. Log of 1 to log 1, anytime you log a 1, you get 0. As long as you have a base that is not negative, as long as you have a positive base that's not 1. Well, your base is e, so you're good. The only time you can't log a 1 and get 0 is if you're doing something like log of -2. That's D and E, right? Because you can't have a negative there. Or maybe a 1 there. You're not allowed to have a 1 there either. You can't have a 0 there. But that's always going to be 0 when you log a 1 and the base is okay. Here, our rule is when you're logging, what do you know about these 2 values? They have to be what? They have to be greater than 0, and that one also can't be 1. Well, look, that's not greater than 0. D and E.
Yes, yeah.
Okay, so besides the review, what's